Good morning, students. We will now solve double bar problem. Okay. So in your exam, either single bar problem or double bar problem will come. So this question is fixed question in your exam. Okay. So here, if you see what is given, two bars are there, bar one and this is bar two. Okay. Young's modulus is two. Is actually two to 10 raised to 5 Newton per mm square, and Poisson's ratio is 0.3. Okay. So first bar length is 30 mm, second bar length is 60 mm. The force is applied on the right side of 1000 Newton. And what they have given the area of bar 1 and bar 2 directly. So in bar 1 problem, that is previous problem, which we solved, in that only diameter was given and we had calculated the area. So here, area directly has been given. So area 1 is how much? 40 mm square, and area 2 of bar 2 is 20 mm square. Okay. So let us solve this in the Ansys. So go to Ansys. So go to file. Here start new. Do not read file. Okay. Then say yes. Then go to file. Change job name. Change title. That you can do it later. Then go to preferences. Go to structural. Say okay. Then preprocessor, element type, delete. Say as. Now this is bar problem. So bar problem means you have to select link. Wood is bar 1. Always remember bar problem. Always you should select link. Wood is bar 1 and say okay. So it has been created. The link. Click close and finish this. Then the second option is real constant. Real constant means you have to give the area. So go to real constant, add edit delete, add, okay. Now if you see here, two areas are there, A1 and A2. That is bar 1 ka area and bar 2 ka area. So we have to give the area two times. So first area is 40. So real constant set 1, that is bar 1 और एरिया है 40. मतलब बार वन का एरिया 40. Okay. Then what you should say? You should do apply. तो ये create हो गया set 1. Next is bar 2 का area, that is 20. So real constant set number इसको 1 है, इसको 2 करना और area is how much? It is 20. So bar 2 area is 20. Then now you should say okay. तो ये दो एरिया क्रिएट हो गए हमारे, सेट 1 एंड सेट 2. and close this. Then go to material properties, material models, structural, linear, elastic, isotropic. And here you put the values of Young's modulus 2, 3, 5, and then Poisson's ratio is 0.3. Say okay. So this material property has been given. Next, there is section here, but this is bar problem, so we should not use section. Directly go for modeling. So modeling में क्या करने का है? Go to create. You have to create the nodes and elements. तो यहीं पर है nodes और ये आपके elements. So first we'll create nodes. So go to nodes in active CS. So now here if you see there are three nodes. Node 1, node 2, node 3. नोड 1 का लोकेशन है 0, नोड 2 का है 30, नोड 3 का क्या करने का? फुल डिस्टेंस यू शुड टेक 30 plus 60, that is 90. Okay, let us do that. So node 1 location is 0. Say apply. And node 2 location क्या है? It is at a distance of 30 mm. Here 30 and say apply. ये हो गया, दो नोड्स क्रिएट हो गए. अब थर्ड नोड कितने डिस्टेंस पर है? it is at a distance of 90 mm. Full distance you should take, not only 60. Total distance you should take. Starting से वो point कहाँ पर है उधर तक, so it is 90. So here you substitute 90, then say okay. तो ये हो गए हमारे 3 nodes. 3 nodes have been created. अभी इनके बीच में एलिमेंट क्रिएट करने का है. So what for that what we should do? Here only below the nodes element is there. So go to element. First go to element attribute. Now here real constant set number 1 है कि नहीं चेक करो. Now see दो सेट है इधर. पहले एक ही था प्रीवियस प्रॉब्लम में क्योंकि एक ही बार था. अभी हमने एरिया 2 बार दिया है कि नहीं. तो 2 एरियाज है उसका. अभी पहली बार 1 रखने का. Then say okay. Then go to here down auto numbered 2 nodes. Now what to do? Select node 1 and node 2 and say okay. अभी element 1 create हो गया. अभी element 2 create करने का है. So for that directly don't go to through node, select these 2 points and create. क्या करने का? First go to element attribute again. Now this real constant set number 1 है ना. For this you should make it as 2. Then say okay. Now go to through nodes, select 2 and 3 and say okay. अभी ये एलिमेंट क्रिएट हो गया. तो हमारे 2 एलिमेंट भी हो गए. Now close this everything. Meshing तो है नहीं इसमें. There is no meshing in this because it is a bar problem. So directly go to solution. Now in solution लेफ्ट साइड में फिक्स करना है, राइट साइड में फोर्स लगाना है और 1000 न्यूटन. तो गो टू एंसिस. सॉल्यूशन में क्या करना है? डिफाइन लोड्स, अप्लाई स्ट्रक्चरल. टू ऑप्शंस डिस्प्लेसमेंट एंड फोर्स. डिस्प्लेसमेंट में हम क्या करते हैं? फिक्स करते हैं. एंड इन फोर्स वी अप्लाई द फोर्स. सो फर्स्ट गो टू डिस्प्लेसमेंट. हियर यू शुड सेलेक्ट ऑन नोड्स. Then select the first point, say okay और degrees of freedom okay. तो ये हमारा फिक्स हो गया. Then go to force on nodes. Now select third point because the force is on the third node. इधर force है third node के ऊपर. So you should select third node and say okay. Direction of force is fx only और force कितना है? 1000 न्यूटन. Force is 1000. तो से ओके. ये लग गया हमारा फोर्स. इसको बंद करो. देन अभी क्या करना है? इसको सॉल्व करना है. तो सॉल्व दिस करंट एलएस. ओके. तो सॉल्यूशन इज डन. तो परफेक्ट है. क्लोज करो इसको. देन now what you have to do? Go to general post processor. So what I have told, whenever you go to general post processor, first you have to go to element table, then say define table, then say add, then come down by sequence ls and here ls1, then say okay. Create हो गया ls1. Close करो and then close this. So element table has been created. Then go to directly plot result. To plot. Then here is third option element table. ls1. Okay. तो ये हो गया आपका रिजल्ट. तो dmx is your displacement and smn is your stress and smx is your maximum stress. तो इसका एक प्रिंट आउट लेने का रहता है. ओके. तो नेक्स्ट क्या करना है? देखो प्लॉट रिजल्ट के नीचे ही here only below the plot result in blue color list result is there. So go there. So what you have to do? Here we have to calculate displacement, stress and reactions. So analytically we calculate it like this, right? So same thing we have calculated. We have to check the results in Ansys. So like this table we have to put. So three nodes are there. So three displacements. So displacement 1 is 0. 2 we got this much answer. At 3 we got this much answer. We have to check what we got in Ansys. So go to Ansys. So to find the displacement, where we have to go? We have to go to nodal solution. So go to nodal solution, VOF solution, displacement vector sum. Oh, तो ये हो गया हमारे डिस्प्लेसमेंट. इधर देखो, फर्स्ट डिस्प्लेसमेंट इज 0, फर्स्ट इज 0, तो 0 मिल गया अपने को. सेकेंड, दिस इज द सेकेंड डिस्प्लेसमेंट Q2, 0.375 E minus 2. The same value you write it here. This is your displacement 2. And displacement 3, 0.0187. This is your value, that is 0.187 E minus 1. The same value you write it here. Okay. So these are your values. So remember, displacement where you will get it in nodal solution. Nodal solution. Remember. Then we will check the value of stress. That is sigma 1 and sigma 2. Okay. So for that, what we have to do? We have to go to element table data. Then here this one. Say okay. So these are your stress results. First stress is 25 Newton per meter, and second is 50. First is 25, second is 50. तो हमको कैलकुलेशन में क्या मिला था 24.9, and in Ansys we got 25. So our values are matching. And calculation second stress is 47, and we got 15 answers. So this is also correct. So like this, you should write it in the table. And final one is reaction. So for reaction, you go here only, reaction solution, all items. Okay. So this is your reaction. The reaction में कितना मिला था अपने को 1000 मिला था. Okay. So this is your value 1000. So write it here. Okay. So three things: displacement, stress, and reaction. Displacement कहाँ मिलेगा? You will get it in nodal solution. Nodal solution. Next, stress कहाँ पे मिलेगा? You will get it in element table data. Element table data. Reaction we will get it in reaction solution. Okay. Remember, ये सब list results में रहते हैं. So many results are there. Out of this, only three things: nodal solution, that is displacement; element table data, that is stress; reaction solution, that is reaction. So these three values you remove and write it in the table. Okay. Thank you.